Hi guys, so today we're just going to continue on with looking at exercise 4D and go on to semicircles here. So semicircles, you'll know, is half a circle. And we can find a semicircle by simply changing or transposing the general equation of a circle, which we learned from last class is x squared plus y squared is equal to r squared, where r is the radius, to make y or x the subject. So in this first example here, I've made y the subject, so I've simply put x across to the right-hand side. So y squared is equal to r squared minus x squared, and then I've just taken the square root of both sides, so I've got y is equal to positive or negative, positive or negative square root r squared minus x squared. So this creates two equations. So y is equal to positive square root r squared minus x squared, or y is equal to negative square root r squared minus x squared. And these two equations create two sides of a whole circle, or two semicircles. So this might be a bit confusing, but an example will pretty much clear this up for you, I'm thinking. So first off, sketch. So once again, you just got to look at what form we'll look at. So sketch A, y is equal to positive square root 16 minus x squared. So we've got a positive square root, so we know it's going to be a semicircle. So if we draw out our, using a ruler, like always, label these. Alright, so we know y cannot be negative. So it's going to be positive. So it's going to be the top half of the circle here, because it's got a positive sign there. Okay, and we know that it's r squared minus x squared. So in this case, r squared is equal to 16. Therefore, r is equal to 4. So the radius is 4, which means it's got these intercepts here are 4, radius of negative 4 here, and then positive 4 there. And similarly, when we're looking at part B, once again, you just simply draw up your Cartesian plane. And I want you to see, pause the video here and see if you can graph y is equal to negative, knowing that y always will have to be negative. Where would the semicircle be? Alright, so it would have to be where y is negative, which is below the x-axis. So draw it here, and you've got to try and make sure that you keep the circle even, which is why it's nice to rule out your lines first. So once again, the radius is 4. So as you can see here, looking at each of these graphs, they're the positive and negative versions of the circle x squared plus y squared is equal to 16. But it's just split up by this positive and negative value outside the square root sign. Okay? So similarly, when you've got x squared plus y squared is equal to r squared, you could make x the subject. So take y squared to the other side, and then take the square root, and get x is equal to positive negative square root r squared minus x squared, which once again creates these two semicircles for positive or negative. Okay? So go through another example, very similar to the first one. So we've got A, got y, x, and so x in the first example can only be positive, so it's going to be on the right hand side of the y-axis. So you draw a circle to the right hand side, and we know r squared is equal to 9, therefore r is equal to 3. So the radius, because it's just about the origin, negative 3, is there. Similarly, I want you to have a go, see if you can do B here. Where do you think the circle or the semicircle would show up when x has to be a negative value? So just pause and have another go. Alright, so if you draw it out, it would have to be to the left of the y-axis, as x can only be negative, and it's negative on this side. And once again, the radius, r squared is equal to 9, r is equal to 3. Just need to fill in those points. Let's go on to the next video for a more complex example here. You can also have a look at example 11 for